It will be.
No, sir. They've not sent it to him.
Hello, sir.
Yes.
Sir, please, I learned you said you are going to discuss when we meet.
No, I never say so, please.
Please, you can hear me.
I said I never say so.
Okay.
So now we are coming to move to the second model. So under this model, we are going to consider science, engineering, and engineering technology. Okay, the objective of the model is to introduce you guys to the basic differences between science, engineering, and technology. We're also going to establish the relationship between science, engineering, and technology. So let's start from the concept of science and engineering. Science determines how the natural world operates. Engineering applies science to make products. Okay, to make products. Technicians use products, follow procedures and maintenance. I think my background is noisy. Oh, Herbert, open the energy lab for me, please.
Sir,
I can hear you.
yeah,
The
please
place,
come again.
I said the place is noisy, so I'm changing my location. Okay.
Okay, sir.
Herbert, do you have internet there? Do you have internet over there?
Yeah, I have internet, sir.
Oh, no, I'm not talking to. I'm talking to somebody in the school.
Uh,
I'm on campus. That's right. I think there's a funeral going on. 800. Use the switch. All right, so let's start now. Okay, so the concept of science and engineering. The first thing is that science is by nature. Okay, nature as in change in weather, right? Uh, production, I mean, reproduction in humans, in animals, all that is science, right? Science proves all these things. So science is to prove a natural phenomena, okay, something that occurs around us. It could be a science of study of human beings, the behavior of human beings. These are all classified under science. That's why we have human science, okay? Then then we consider the engineering. The engineering applies science to make products. So engineering would depend on science to come up with something that is artificial. Okay, that is human made. Then that brings about engineering. For example, there is some insect, okay, that when it is attacked, it shoots hot water. It shoots hot water, and then the speed with which the water gushes out from itself, right, is so amazing that it's a prey that attacks it rather is rather consumed by the water. The water is very hot. So they use this technology and now they cut the sides of roads. Can you imagine? Road, the asphalt, they use this technology to cut it. They use the same technology to cut metals. Okay, they use the same technology to shape metal gears. They use water to cut it. You can imagine. They use the same technology to clean the teeth. That's what the dentists use to take tartar out of the mouth. All right, so technicians use the product. So this is where you find yourself. When we get up there, we call ourselves engineers. Engineers, what do we engineer? We don't engineer anything, we are technicians. An engineer is somebody who comes up with a product using science, okay? Do a lot of research and then come up with a product. For example, somebody came up with electric car for the first time. producing an electric car. That is engineering. The technician is the one who utilizes or who uses the engineered product or the product that has been engineered. So a technician work on or repairs a car. When there's a part that is broken or damaged, he can fix it, or he can repair it, or he can replace it. That is a technician. But most of the times we confuse the two and we say is a telecom engineer. What have you engineered? You understand? Okay. So we have scientists do discovery. Okay. Scientists discover, they understand what they discover, and they can explain it. Engineers don't need to go do discovery. They need to work on what the scientists have done already. So they design and create based on scientific facts. Then the technician operates, maintain, you understand? So if somebody has designed and created a car that has 8 wheels, okay, that can turn around on itself 360, that can fly, and you are maintaining it or cleaning it, or let's say you are repairing it, it doesn't make you an engineer. You are a technician. Same way, a scientist is not an engineer. Likewise, an engineer is not a scientist. All right. So, for example, X-ray. The X-rays. Scientists discovered X-ray. Okay. Scientists discovered X-ray. Then engineers will design X-ray machines. You see that? Then technicians operate, maintain the X-ray machines. Have you seen? So if we can all place ourselves very well and we know where we belong, and then we are ready to work together. Okay. For example, we'll go for a scientist from, let's say, KNUST. Okay. Somebody who is a scientist using scientific methods. Okay. You do a lot of research and say that, oh, it is possible for human being to teleport from Ghana to USA without visa. So human beings can teleport across the world and even across different dimensions. That is a proposal, okay? And the person can work around it and get scientific facts and say that human beings are made up of atoms. Atoms can break apart and they can be joined together. And when they join together, they form the human being back. So what do? Now the engineer will come and say that, oh, I can design a machine that can split the atoms and then join the atoms somewhere else. Okay, he designs the machine. Now it has become possible for somebody to teleport from Earth to the moon and from the moon back to the Earth. Teleport from Earth to Jupiter and come back. Okay, it is possible. Now it is done actually. Now that it is done, there's a fault to the machine. The technician will come and check and then be doing the repair works. Okay, if it's this part that is fault, you can look around it and then study it. Know what it is now. You can now fix a different thing and even improve on what has been done. You see that? So I'll just give you an example. The next is a lasers. Okay, so how engineers work, engineers, scientists, and technicians work. So the scientists invented laser machine, use lasers to do research. Then the engineers design applications from the laser. Okay, so several things will come the from the laser that has been discovered. For example, we have planted corn, right? Once the farmer plants the corn and you harvest the corn, whatever comes out of it, when he sells, that's all. He doesn't have anything to do with the corn again. He has finished his job. So the scientist invented it. He invented a laser and then did a lot of research with concerning lasers. That's his level. He's finished. He doesn't need to do anything again. Now the engineer will say that, oh, okay, this laser that has been discovered, I can find something to do with it. I can create something out of it. So, for example, the corn that the farmer harvested cannot be changed into popcorn, for example. You can mill it and get corn dough. Some people can even get corn starch from the same corn. Some people can get corn starch. Some people can get the flour. Some people can get paper. Can you imagine paper? Some people can get biscuit from it. So many things. Then when all this is done, distributed, then you see that somebody can make cocoa out of the corn. The corn has been made already. I mean, the corn dough has been made already. So the one who prepares the cocoa from it is just using the corn dough. He didn't do anything to it. So those people are at the surface. They don't necessarily need to know how the corn came about. No, the cost of producing it. No, they don't need that. They only need to know how to prepare it for it to be consumable. So that is what scientists, engineers, and technicians do. So, okay, so what is engineering technology? Engineering is an area that requires expertise in the applied science, mathematics, and social science. Technology is an applied science which involves the mechanics, practices, and activities of producing daily use products. Engineering technology is a scientific study of converting natural resources into tools and machines which eventually will fulfill the needs and demands of ever it's supposed to be changing, okay, not charging, ever changing society. So let's take the definition again. This is a very good definition. Engineering technology is a scientific study of converting natural resources. So we take natural resources, we change it into tools, machines for the purpose of what? Human needs. Okay. So anytime the society evolves, anytime the society moves on, we need to have the tools and the machines that matches with it. Of course, look at where we have gotten to. We are in the era of information. Okay. So era of information, people need to do cybersecurity. All right. People need to go into IoT, Internet of Things. People need to go into so many studies. That is why you are here. You see that? So whenever society changes, the demand goes high. That's why now we are using smartphones. My time, we were using the phone booth. There was no, we were using telephones. There was no mobile phone. There was no mobile phone. If you want to call it, it's purely landline. Then eventually, the landline started fading off. Now they are gone completely. So engineering technology should encompass the following. One, product manufactured should have commercial value and quality. This is where Ghanaians we are having problems. Whenever you produce a product or you come up with a product, does it have the standards that meet the international market? You have to consider that. It is something that people, it will not stay in the market for only 3 days and go. Will it sustain? Resource management must be efficient to avoid unnecessary wastage and distraction. Like the pure water, I thought I spoke about it the last time. We produce pure water without considering the harmful effect of pure water. So we litter all around. We should have first considered how to manage the rubber. Okay, the rubber waste. We're supposed to manage it first before mass producing. When you look at the lifestyle of the whites, they do a lot of that. They will do the studies and realize that no, this product, if it comes into the market, even though it is good, it's going to cause a lot of harmful effects. So they will not bring it to the market. I tell you, there are a lot of technologies that are on the shelves. They will not bring it out because it is going to be very destructive. Preservation of the well-being of environment and human life. As you see, just go and bring any chemical. You say it is fertilizer. Go and sprinkle your farm with it. Before you realize the produce will come big, all right. But the chemical content, anybody who keeps taking in that product within 3 years, you see, now you see the harm we are causing to ourselves. You go and buy pawpaw. You think you are eating pawpaw, but you are eating something else. You go and buy alubin to green, it's something else. You go and buy plantain or even plantain, it's something else. Yam, something else. As for cabbage, they don't talk about it. Chili pepper, all of them, they sprinkle them with a lot of harmful substances. Even the fowl you are going to buy for salad or for Christmas, the fowl, they've injected with some chemicals until the chemical drains completely from it. Woe unto you if you eat that fowl. But we don't know, then we eat it anyhow. You see? Now you say you are going to fetch, you say you don't want to go to the drugstore or go to the hospital. You take herbs. You go and take herbs to prepare some anti-malaria concoction for yourself. Oh, before you realize, then it has been sprayed with chemicals. Somebody sprayed it with chemicals in order that he wants to clean his environment. He doesn't want to read, so he will spray weedicides. You see what is going on. So he said that society demand for the need of a particular product. So if the product is not needed in the society, when you go into it, you are only going to waste your time because nobody needs it. Social, cultural, political, and intellectual aspects. So before you come out with the product, you have to consider all these things. Okay, society, the culture of the people, the political aspirations that the people are aiming for, then the intellectual aspect, you see how intellectual the people are. Then you come up with those products. For example, you are here, you want to come up with education aid. educational aid. Then you go to a village at Nakpanduru. Then you go and bring, let's say, computer. I'm just setting an example, please. Let me use my hometown so that you don't feel offended. Maybe you are from that place and you say that I'm being biased. Let me use my hometown. You go and bring, let's say, a laptop which is 30 gig. Laptop 30 gig. Then you send it to the domain that are going to give it to class 5 children. They don't need it. 30 gig. What for? Or you go and buy iPhone. You say, oh, we are doing computer. So you buy iPhone for each student in the school. What for? When you could have bought something simple. This is so intellectual, political, social, cultural. So engineering technology, therefore, helps to solve problems in daily life to make it more comfortable and safer. Unfortunately, we are rather making it uncomfortable and we are making it dangerous. Look at what is going on at Israel and at Iran. And look at the activities United States of America. Look what they are involving themselves in. This should tell you that we are rather bringing up distraction instead of to maintain. So let's look at the diagram. So technology, science science takes from natural resources. So we discover gold, all right? Then we use technology to extract the gold. Then we use engineering, okay, machinery to smelt the gold, change it into gold bars, rings. Then the art and craft comes in. That's where the technicians come in. They will shape it and make it look nice. Then they say engineering complements natural resources. That's science. They say engineering can complement, will lead to the bringing of new technologies. And then the availability of new technologies can bring about more natural studies or study into more. Because, for example, because we are able to design a new machine, a machine that can research more into arsenal, then we have to look for arsenal to check what it can be used for. You understand? So they complement each other. If you have a question, you can ask.
Yes, sir, your network is breaking. It's not smooth. We are having break in your.
Is that why you put up your hand? Engineer Philip,
Yes, sir.
is that why you put up your hand?
Yes, sir.
Okay, Engineer Philip, let me ask you a question. Be sincere. Which engineer are you?
Sir, your network.
I know this one I can hear.
Yes, sir.
I say, which engineer are you?
I'm engineering craftsman.
Okay. What do you craft?
Okay, sir. So I craft like I make signal generators, and then I make
No, you're
I
not
use
talking. What do you craft? Electronics, right?
please, that again.
Electronics, oh, Engineer Philip.
Yes, sir.
I said, are you not into electronics?
Yeah, into electronics.
Uh-huh. So you can design uh, signal generators.
Yes, sir.
You can design what do you call it? Transmitters, radio transmitters.
Yes, sir.
Okay, that's good. That's good. Okay.
Sir, I don't know if you can do something about your network because
It's not my
your
network, but maybe it is from your end. My network is
yeah, I
popping.
don't know whether it's me because I can see that someone also comment in the comment section that your network.
Oh, please, let's all answer. Is it my network?
Please, am I the only one?
No, sir.
Which one is no?
I'm siding with engineer. I'm also having the same problem.
Oh, oh, sorry. So what do you do now? It's not my fault too. Is it better?
Yes, sir. Yes, sir. We'll cope. We'll cope.
Okay, so let's continue. The impact of technology. In fact, this age, this age has witnessed a lot of drastic change. We call it destructive technology. Destructive technology. When we say something is destructive, okay, well, let's go on. It will come. Product and services in engineering technology are of several forms, including instruments, thermometer, barometer, vehicle ship, car, motorcycle, aviation. Then when we come to equipment, we have sporting gear, X-ray machines, and then smartphones. So we categorize them into instruments, vehicle, and equipment. Then we have accessories, audio systems, amplifiers, lighting, that is touch lights, acoustics. Then we have services, health, okay, communication systems. You see this online delivery, it falls under services. Human needs, food, clothing, accommodation. These are human needs. Then we have industrial applications of technology. Look at that. So we state area of technology and we state where the examples of importance. Energy and power to operate various instruments, control and monitor machines. Then we have domestic and industry, sport and recreation and education. Okay. We have agriculture, construction, skyscrapers, bridges, you understand, houses, health, like we said, the X-ray machines. Okay. We have the wearable technologies. Then we have manufacturing, industrial goods, the new robots that are coming now, computer, numerical control machines, and what have you. Then we have transportation, the buses, the electric cars that have come, ship, bullet trains, and what have you. Then communication, computers, computer networks, wireless network, telecommunication, and satellite systems. So we have the e-commerce and commerce. We have the defense. I mean, they are all there. So in summary, science is a body of natural explanations for apparent phenomena. Technology is a tool, okay, including methods. A tool does not necessarily mean that it's a screwdriver or something like that. No. Softwares are tools, okay, that assist people in accomplishing tasks. Engineering is a process of studying and developing technology. But the quiz is there. Please, you go and do. Are you okay?
Yes, sir.
Model 3. Engineering design process. So what we go through in designing, the process of designing. So this is peculiar with those who want to go into manufacturing. Design is a creative planning process that leads to useful products and systems. That brings about simulations. Okay, we simulate using a simulator as engineers. We don't do try and error again. You simulate on a computer to see how viable it is. Last time I watched a documentary on how that ship, aeroplane at China, how it fell. So it was a new plane, and then they wanted to know, I mean, they wanted to study it. You don't need to go and fly a plane before you can study it. You have to do studies on ground. So they created an application whereby you can monitor the way the plane flies and lands. Okay, so these are called simulations, and it is through the process of designing. So you have criteria and constraints of designs. Criteria, this identify the desired elements and features of a product or system, and usually relate to their purpose or function. Constraints. So we talk about the size, the cost, okay, establish the limits of the design. So when you start simulation softwares, you will understand this one. What is the design process? The design process is a purposeful method of planning practical solution to problems. So you are planning practical solutions to a problem. So if it is that you are constructing a circuit, like Mr. Is it Mr. Ernest? No, Engineer Philip. You want to construct an electronic circuit. You don't need to you don't need to just jump and go and buy any component and go and construct the circuit. There are a lot of things you have to consider. Okay, among your consideration will be the design process. Okay, the process you go through your design. The process you go through with the design. Design process is a purposeful method of planning practical solution to problems. The design process is never final. There are always multiple solutions to a problem. This is another problem we have in Ghana. What we do is that once we come up with a product, then we are quick to make noise about it. Oh, this company has produced this. Oh, this company has produced this, without considering whether is that the best or not. Once it has been done, that's all we rush. So before you realize, the whites have copied what you have done. Example, you have designed a circuit, an electronic circuit. Instead of you to wait for you to see the result of it, then you quickly jump and then send it to the market and go and start selling. Okay. So design process can be defined as the management of constraints. The management of constraints. We have under it negotiable and non-negotiable. The first steps in the design process is identification. So you need to identify the problem. You see that classification and selection of constraints. The process of design, then proceed from here by manipulating design variables so as to satisfy the non-negotiable constraints and optimizing those which are negotiable. Okay, so there are some factors we can easily manipulate, and then there are some we cannot manipulate. So those that you can manipulate, they will be there. You utilize those that can be manipulated to achieve those that you cannot manipulate. Okay. Typical stages of the design process include pre-production design. So pre-production design is the initial stage you go through. Whilst you have not started the production yet, you go through a lot of work. For example, you do simulation. Okay, you do simulation to test to see. It's a pre-production design process. So let's see. The first one, the 9 steps. So the first one, starting with the statement of design goals and objective. So that's definition of the problem. In fact, the steps you are going to go through is almost the same as doing a research. Okay. So define the problem. The problem is you have identified that Ghana is too filthy. That's a big heading. You have identified that Ghana is too dirty, or you say Ghanaian youths are indisciplined. It's a big headache. It's a problem. Okay. So you start from the design definition of the problem. Then you end at what? Communication of the results. Okay, so let's see. We have the engineering design process. There you go.
Sir.
Yes, I
Hello.
can hear you.
Sir, I want to make some comment about what you said earlier that uh like we Africans when we start something or we start to
Mm,
manufacture something, we are quick to announce it. Like
mm,
we don't work behind the scene and make sure that the thing
working.
is like valid and improve upon it. But in the
Exact-
early stage, then we try we
Hello?
manufacture the this thing the the CPU.
Uh-huh.
Hello,
I can't hear you. Say it again.
hello.
What did you say before saying manufacture of the CPU?
That's it.
Can you hear me?
Oh,
Engineer
in
Philip. Engineer Philip,
yes, sir.
can you hear me?
Uh-huh.
Please talk a
So
bit. Uh-huh.
so I came across a lot of Africans who
Mm,
started something like started to bring out something like engineer something. But at the early stage, you see them like advertising the thing instead of work on the thing and make sure that the thing is successful.
it's a finished product.
Yes, they will not do that. So at the early stage, they see that some the white people they will just copy and they
I
work
tell
behind
you,
the scene.
I
So
tell you,
before you see,
exactly.
then they come. So I
It's a,
experienced this when I was very young. When I was very young, I used to like use some Milo cans and make some lights and like I do a lot of things. So when I start if I start the project, I during the starting, no, then I will be telling people this is how I want to do it. This is how if I sleep before I wake up, the thing all the plan will go.
mm,
All what I plan, how I wanted to do the thing, it will like I will not be able to finish it.
mm.
So this is what is killing
You are not alone. Okay, there are a lot of things, a lot that was engineered here, right here, but we share the ideas quickly. Let me tell you, when I was around, when I finished SHS, when I finished SHS, but then we those days we used to go to the internet cafe, okay, for emailing and what. You go to internet cafe. Internet was not that common like this, so if you want to browse, you have to go to the cafe. I had a very brilliant idea. It just came into my mind like that. It was about uh, the watch that takes heartbeat, that uh, it checks heartbeat, it checks, I mean, your blood pressure, your blood sugar, and all that. I was the one who brought up the idea. I tell you, you won't believe it. You won't believe it. I brought up that idea. When I finished SHS, so that I was overwhelmed. Like I couldn't control myself. I was so excited, just looking around me, who was there to assist me to come up with this idea and make it successful. I wasn't finding any hope anywhere.
mm,
I couldn't hold on to it for a long time. So I requested for a communication between myself and Nokia. Nokia. I managed sent the mail. Those days when you send a mail and your money finishes, your money has finished to happen, you go so that
Mm.
another person come and use the computer. It's not yours. So I requested for a meeting. They replied me. And then when they replied the mail, I asked that they should assure me that what I'm coming to reveal to them, they'll give me compensation, right? They're going to pay me for giving them these ideas. Oh, they agreed to it. That oh, they are ready. Once the thing is something they have not seen before, they will. Then my credit got finished. I mean, my money got finished, so I had to leave. I wasn't having money, so till the next day,
Okay.
I came again. I sent them a mail. Then I told them that what I'm coming to tell them, they have never heard it and they have never seen it before, and I don't think any of them has thought of it. They say, "Wow, okay." So they requested those days they will give you time for a chat. Okay, chat, live chat. So you are having a chat room, like a chat room, yes. So you'll be typing and they'll be typing. That's the communication.
Um,
They gave me time. They sent me a mail and gave me time that 2 o'clock, sorry, 12 o'clock to, it was 40 minutes communication, 40 minutes. So 12 o'clock subhanallah, 12 o'clock to 12:40. No, no, it was their time, not my time.
mm,
Their time, US time. Come and see ignorance. I went to the cafe 12 noon, hoping to meet them. Opening the link they sent me, only to realize that say the time has elapsed. Oh, they came and waited and I wasn't there, so that's all. It has elapsed. The way the thing pained me, out of frustration, out of frustration, then I just jotted everything, typed everything. I said, we should go. Whatever may happen, at least I will be proud that one day I'll be proud that I'm the one who brought up this idea. I promise you, I had not heard of that anywhere. Neither I have it. I was sleeping in the night and it came like that. And I know they never saw anything like that. They never thought of it. Come and see the day I came to level 100 after I went to a training college. Actually, I'm a trained teacher. That's after 4 years time. Apple, is it Apple? Another, Nokia. Nokia had released their first wrist watch, which is a phone, because the specifications was that the thing should be a phone, a hand, it's a wristwatch phone. The
mm,
wristwatch phone should be able to like, receive calls. It should be able to, it should be able to take your body temperature, okay,
mm,
take your pulses and then your sugar levels, and should alert you when your blood pressure goes too high, okay, and give you possible recommendation, first aid,
mm,
that at this point in time, sit down, relax, or lie down, take off your shoes, those kind of things. It was all in the specification. They did not bring all the specifications at once. They started introducing them gradually by bringing in the phone, which is a wrist watch. That was the first thing they did. When I was at the university, I said, wow, it has eventually come. But who are you going to tell? By then, my chat with them had been deleted long ago. Long, long ago. I say it was amazing that all the chats I had with them and the sessions I had with them cleared completely. Cleared. So they asked me, why did I choose Nokia? If I'm telling lies, like I wouldn't be telling you this. They asked me that why did I choose Nokia? I said, oh, well, the name alone, and then it's a major brand. I said all these things. I couldn't defend it because I was so naive. I was so naive. That is it. So we get this information. We don't know how to handle the information. And
Mm.
then they to slip through our fingers just like that. Imagine if it was me, a white man who had this information and had the resources. By now I would have been cruising. Eh?
Yes, sir.
I would have been cruising in what do you call it? Some
Tesla.
place. Oh, Allah. You see, but here I am. So what you are saying is very true. I was in primary, I tell you, I can lie down and close my eyes. Then I'll see, I can be imagining what is happening in the photocopier machine. I say I can imagine everything from head to toe, and it is perfect like that. I started designing cars with, I mean, back in this, when I had not seen toy cars that had the wheels, I invented my own remote controlled car. Once I was in class 6, all these things, I couldn't make any good use of it. You understand? So this tells us that as we are aging, as we are growing, if we detect that our children have this kind of talent, we should guide them. We should guide them. We shouldn't be insulting them. We shouldn't be discouraging them that to go and take your books and learn. Go and take. No, you should blend the two because it's a gift. If you don't get anybody to treat you well, you lose it. A lot of things Safo Kataka has done. A lot of children in Ghana could have done it better. A
Yeah,
lot
yeah.
of children, a lot of children in Ghana could have done it better. But quadcopters. I mean, we made all those attempts. Producing helicopters, we made those attempts. But who was there to guide you? To give you the knowledge. Talk of the cocoa machines and whatever. There are people who are doing a lot of things, but to come to the limelight, it's not easy like that. You see, we're trying to relate the technology, the science, and then the uh, engineering together. And then also talk about the technician, the scientist, and then the engineer. This is the problem we are having with various institutions. If if we are a material engineer somewhere, and another person is an electronics engineer, another person is a concept engineer, you see, we need to work together to bring up something, tangible. But no, the electronics engineer will say that once I'm the one who has the skill in the electronics, I must be the one to do everything. So he will force himself to become a material engineer. Meanwhile, he cannot get the correct material for the product. So the product will come out and it is not nice. He's a concept engineer and he's forcing himself to build his own circuitry. It won't work. So please let's take notice of these things. Okay. Thank you for your contribution.
Okay,
The
sir.
engineering design process. Okay, so that's it. So elements within the engineering design process. So these are the things that we are going to list. Okay, from 1 to 11. These are the things we are going to consider when we want to design something. First, identification of problem. Okay. Second, you have to do research. Okay, research, we call it literature research or literature review. You have to search and see the similar works people have done. There was one, let me share something with you. I come from Volta region, and then I was thinking, what economic activities can we bring to voter region to make it lucrative for people to live, or transportation, make it easier. So something quickly came to my mind. Why don't we do Okada on the river? Okada on the river, it doesn't sound interesting. So quickly, I started thinking about putting some gallons together, right? Putting some gallons together and then put Okada on it. So it becomes like a Pragia. At the same time, it can carry goods from, Volta region, they have some islands on the lake whereby people can go and farm, but to bring large produce from the farm becomes difficult. So they could have used it to transport, products like palm, fruits, and other things like that to the riverbanks. So I was thinking about this, then I said, oh, okay, let me go to YouTube and see what people have done. Come and see. Indonesia. Taiwan. They live by the river. The people are so creative. Somebody who doesn't have any education, oh, we're not talking about people who have been educated. People who have no education, come and see the craft they have done. They live on water. That's when I appreciated that really necessity brings about innovation. Necessity. That's their livelihood. So they must try to innovate to survive. You see, but we are not able to do these things because whatever you need is around you. You just get up and tap a point and eat. Who told you so? Go to Germany. Go and tap a point and eat. You understand? Just get up. You feel thirsty. Oh, you just drill, you just dig anywhere in Ghana, dig borehole you get water. Go to Saudi Arabia and go and drill borehole. Go to the Sahara Desert. You understand? Necessity brings about innovation. So you have to do research, okay? Gather information. Then idea generation. Now you compare what you have thought about the problem and you look at what people have done. Then you bring up the idea that suits your environment. Okay, so even though somebody did it and he did his own with a jet engine, okay, for the Okada or the Praga to move on the river, he used the jet engine. You can say, oh, the jet engine will make the thing go faster, but it will make it difficult to control. So why don't I use the normal Okada engine so that it will take its time and paddle the Okada or the Pragya smoothly on the river so that I can carry heavy load. You see that? So you are changing somebody's or a lot of people's work, and you consider your terrain, your environment, and design something that will suit your environment. Okay. So that's idea generation. Evaluation and selection of solution. So you created a concept, you created the idea, Pragya on water. So you have to now evaluate it. Is it really necessary? Is it really necessary? Or can something else be done about it? Can I change it a little? They'll be thinking, this is what engineers do. You'll be thinking, what about if I rather use propellers? Okay, why don't I attach some planters to it so that when it goes to the island, it should be able to plow? Because it will be difficult to go and plow on the island. So why don't I go and send some, create a part of the Pragya that can plow the land so that as soon as it gets to the island, right? I'll just take out the part that is making the Okada float, and then fix the ties, and then fix the plows or the planters, okay, so that it will plow the farm. You see that? So now you'll be doing re-evaluation, okay? That is where your final solution will come. Then, when you have done that, they come to development of design. You have gotten the idea already. This is a mental work. Now you have to design it on paper or using a software. You design it nicely. When you design it, now you come to construction. Okay, building a prototype, a small one. These days, there are 3D printers. So you print a small one. When you print a small one or you build a small one to test to see whether it will work. So what you do is that you find a bowl or a jerrycan of water, or let's say a pan of water. Then what you have designed is very small like that. Then you immerse it, you put it on the water to test its flotation abilities. Test and see. What about if weight is here? Balance the weight. How will I do? So if the prototype is well balanced on the water, then you can imagine that, oh, okay. Once the small one is working, the big one will work. Sometimes you can even do that and attach harsh condition to it. Okay. You put some weight here and see if it will balance it for it to sink. Or you put it here to see. Or you can say, let me disturb the water and see if it will sink. When you finish with all that, then you consider the weight of the material you used and find its equivalent proportion. That's when you can rate and say that, oh, this tragia can carry only 100 kilograms. Beyond 150, it will sink because you have done the prototyping. You've built the miniature. After you build the miniature, then now you analyze, okay? Then you interpret results because you were doing this thing. You were testing. Then you interpret the results and check. Then communication and presentation. So now you have gotten the idea. You may not be the one having the money. This is a challenge of engineers. The biggest challenge we have. Most engineers don't have money. The correct engineers themselves, I tell you, correct engineers, they don't have money. You see how God works. The real engineers don't have money. So they always have to partner with people who have money and position. So talk of somebody like Nikola Tesla. You understand? He had to migrate to come and work with somebody in order to let his invention come. Before you do that, the person will steal a lot of his works. The correct engineers in the world don't have money. And most of the times they are cheated. That's the problem we have. Oh, there's an accident on my road. Oh, okay. So communication and presentation. So you have to discuss it and you present it to people who can assist you. Then reflection and iteration. So you have to go over all over again. You have to go over and over again to check the viability of what you are doing. And also check, are there no errors here? Can I do it this way? You have to keep on doing that. It's like a loop. You have to keep on doing that. Then ethical consideration. You have to consider that is it not exactly somebody's work that you are producing? After you have done everything, is it not the same as somebody's work? Or are you not stealing from somebody? You understand it? Okay. Then collaboration and teamwork. Now that you have come up with a product, you are confident, so you can call people to work together with. You have come up with a concept. So now you distribute the concept, you distribute the work. For those who are computer programmers, come and take their part to program the motors for them to work the way you want them to work. Electrical engineers will come. Electronics engineers like yourself will join. Then you have maybe mechanical engineers will also come. So you see that it's a teamwork. See? Now that you are the one who brought up the concept, you become a team lead. A team lead does not necessarily mean that you should know everything in the production line. No, it's not necessary. You can stick to one department and give instruction that I want it to be like this, I want it to be like this, I want it to be like this. Okay, all right. Any question? All right. So everything has been discussed here in the circular form. So under the problem identification, you have a long list. You have to consider that, all this. You have to consider all this. Material properties and all that you have to consider. Please read them. So you see that. So you come to the design. I mean, these are all subheadings under the main headings. Okay. Build and test in the prototype. So you have subheadings like select prototyping methods, construct prototype, ensure accuracy. All these things are under the prototypes. I mean, under the headings. The seventh one is analyze and interpret results. We discussed it. Then the eighth one, communicate and present. Okay. So you see, compile reports, include specifications, like I said, record changes, say create diagrams and drawings. You see, generate 3D models, like I said, using 3D printers. Then prepare charts and graphs. Okay, understand the audience. Then reflect and iterate. This is a critical phase in the engineering design process where the team reviews the entire project. You see, like I said, it reviews the entire project to assess its success. Even after you have gone through all that process, oh, you have to reassess its success, learn from the outcomes, and make necessary adjustments. So that is why we don't say that because I am the team lead, I have brought up the idea and then it is working. So when somebody comes, especially your subordinates, some small boy will come and say that, oh, say, why don't we do it like this rather? Eh? The metal, we are using aluminium. Why don't you use metal, this iron at once? This we are going to use plastic for. Let's use metal so it will be durable at once. They say, hey, this boy, when did you complete school? What do you know? Do you have a PhD? What do you know? We talk, 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 talk. And the boy say, ah, okay, fine, no problem. Then here's what you keep quiet. You keep quiet and then the whole project will be sabotaged. It will go down. Okay. So assess project goals. So compare the final design against the original objectives and requirements to determine if the goal were achieved. Okay, so you look at all these things under that heading. Then ethical considerations. This is the engineering design process which involves evaluating and ensuring that projects design, development, and implementation are conducted in a responsible, fair, and best interest of society. These considerations are vital because the decisions made by engineers can have significant impact on people, communities, and the environment. Here is an explanation of the role of ethical consideration in the engineering design process. So risk assessment. You have to assess, see how risky the thing is. You are working and then you are using a type of cable that has low resistance. Okay, the wire, the insulation around the cable is weak, and then you are passing a very high voltage in it, and you are going to connect it to a three-phase motor. You can imagine a three-phase motor. I remember, good. Let me remember. Say what about what I experienced some time past. My first time, I was going to wire a friend's container, a female friend, and then the father, the way, hello, the father didn't trust whether I can do it or not. And in fact, it was my first time. She too, she wanted me to do the thing for her. Okay, fine, no worries. I went and did the connection, did everything, forgetting that wiring the container is not the same as wiring the block building. Wiring the container is far different. You have to make sure that the copper wires, okay, the wires do not have direct contact with the container. Not that they shouldn't touch the container, that one no problem. But when you bend the wire, like you are exiting from the container to go and take power from the mains, and you bend the wire, so I didn't put the pipe there. I just did the connection and then went and was trying to, tap power into it. Come and see, boom! Say, yeah. That was my first time. I said, whoa. I was thinking that, why? I went home that day, I didn't sleep. I thought and realized that, it's a container at the top where we perforated it. And we brought out the wire. We bent the wires, the black and red. We bent them. So its insulation, right, was lesser than it was supposed to be. The resistance it opposed was lesser. So that brought about the short circuiting. Since then, I learned my lesson. And since then, that was my first and last container wiring. The man didn't allow me to continue. I did whatever I said, no, you won't allow me to continue. So I learned my lessons from that place. But it was just something I was curious to do. I wasn't an electrical engineer. I mean, electrician. No, I'm not an electrician. I was curious to learn it. You see, and then the type of cable I was using to was a 2.5 cable. I just needed 1.5 cable, but I sent 2.5 cable there. You see, so that's it. So you have to consider the risk factors, safety standards, compliance. Please, if somebody gives you a job that you don't know, eh, don't force yourself that because I have a degree in it, so I must be able to do it. No, if you don't take it, you disgrace yourself. If somebody gives you a job and you don't know, right, you can play smart with it. Yes, you can take the job, all right. Go and call somebody who also knows the job and knows it practically. You may know the theoretical aspect of the job, but you may not know the practical aspect of it. Go and call somebody who knows the practical aspect of it. Tell him to charge. He will charge you, and then you will come in also charge because you will definitely add your expertise to it. After you have done that, then you now move with the person who has the practical knowledge, and you also learn from the person. That's how it goes. Okay, so the fact that you have done electronics does not mean that every electronics job you must be able to do it. When it comes to learning, you must learn, but you must not do everything you learn. Okay,
Okay.
why is it time?
No. No,
Okay,
sir.
let's go. So collaboration and teamwork, you see, forming interdisciplinary teams. You see, forming interdisciplinary teams. I like this a lot. You see, assemble teams with members from different engineering disciplines, mechanical, electrical, software, and other fields such as marketing, finance, you see, finance, and or user experience. You see that? So when you team up with all these people and you come up with a product, the product is solid. It's solid. There's no way you hit the market and you lose. And though you are going to distribute the money into all these people, you will feel like, if it is me alone, I would have gotten all these profits. The same way if it is you alone, you would have come up with a very bad product. You see. So all these things are there. You need to consider. Then documentation. Yes, this is where you have to documentation, documenting solution and solution requirements. So the you have to patent. This way you have to patent. Okay, you have to patent. You have to go and do registration. And then the list goes on. So we come to engineering ethical consideration. See, privacy and confidentiality, minimizing harm. So you are producing fruit juice. The fruit juice that you are producing, there's no fruit in it. There's no fruit in it. And then you are only using chemicals, flavors upon flavors, adding sugars and flour. You mix them, then you can put it on the market on the shelf. That this is mango drink. And naive people like myself will go and take and drink. Hmm. So we have NSP. Okay, they adopted the following. So the following are the criteria, or let's say the creed for every engineer to follow. Okay, to give the utmost performance. Okay, to participate in none but honest enterprise, to live and work according to the law of man and the highest standard of professional conduct, to place service before profit, okay, and honor and I say the honor and standing of the profession before personal advantage and the public welfare above all other considerations. So we need to consider all these things as an engineer. We are finished with model 3.7. Model 3.8 is quiz and assessment. Please be considering the assessment. So these are solving the questions. Okay. Is there any question? Okay, no question. PCB technology and breadboard, PCB technology, breadboard, and soldering principles. All right, this is going to be fun. PCB. Okay, so let's start with the main objective of this model. We are going to introduce ourselves to the use of breadboard for prototyping. Understand the principles of soldering and techniques. Printed circuit board, that is a PCB, okay, manufacturing process. So let's start with prototyping. Breadboard and PEF boards are great mediums for prototyping circuits. In prototyping hardware, the design process may evolve from breadboard. So let me see if we have a picture here. So what you see right here, this is a breadboard. We use it to mount electronic circuits. Okay. The next time we come to the lab, I will let you see it. This is a PEF board. We call it PEF board. It's a perforated board, or the matrix board. Okay. And this is a printed circuit board. The Arduino board, it is printed. So your computer motherboard is a printed circuit board. Your amplifier boards are all printed circuit boards. But this one is perforated board, and this is a breadboard. This breadboard is mainly meant for novice, people who are now beginning electronics. Okay. The next time you come, I'll show you all. Okay. So prototyping is just to make a miniature. Okay. A small for practice purpose. It's like a child having to be. So PCB design. This is a PCB design. This is a PCB diagram. And then this is a PCB assembly. The assembly is when you mount the actual components. The PCB diagram is like the pathway, the circuit path that you design and that you create. And then this is a design showing where to place each component. Okay. This simple design lights an LED using basic electronic components. You can create and visualize such diagrams using free PCB design software like Wk5. It's an open source. Then EasyDA online based. Then freezing is also very powerful. The latest one that we have now is called a Tinker card. And that's what I'll be using with you, okay? Tinker card. So I'll use a Tinker card. Your mid-sem is going to be a practical mid-sem. You are going to design and construct your own PCB. All right, I'll give you the circuit, then you work with. Will next week be face-to-face or it will be online?
Please, next week is holiday, so we are not meeting.
Hey, then we meet online, okay?
Yeah, Easter break.
That break.
Okay. So they are all there. We have schematic diagram and we have the PCB layout diagram. Okay. So the purpose of the schematic diagram is logical representation of circuit components. Okay. Then you have the PCB diagram. We have something called the Droid PCB. Okay, PCB new. We have KI card, PCB editor. All these softwares are there to help you get the PCB view. Okay, then assembling a PCB. What is PCB design and assembly? I think these questions you can answer them when you're in your house. So this also tells us the various methods, the advantage and then the disadvantages. We talk about that one. Let's read through this one. Then all these things we are seeing like this, we are going to do them physically. Okay, we do them physically. We will construct them physically. This thing we are seeing like this. All right. So when the time comes, we will do. These are practical things. They are all practical. So during coverage, we are going to do that. We are going to do all these things. Okay, so basic electronic components. Basically, electronic components are classified into two. We have active components and then passive components. So we are going to see them. There are many various electronic components and it is difficult to be covered. It is difficult to cover all of them. So we will examine the most important, common, and widely used components in electronics. So all what you are seeing here are all electronic components. So we have passive components. Features of passive components. Very important and essential parts, but they can't amplify the voltage. They can't cause any change in the voltage or current. They can only permit to pass. So examples of passive components include the resistors, all right, the uh, uh, the inductors and what have you. Okay. Then we have a electromechanical component. So this consists of moving parts like generators, like motors. Then we have active components. These are used to amplify or attenuate. Okay. Mainly they are semiconductor materials. They have optoelectronics components. Okay, they emit and receive lights. Okay. When you come to the lab again, I will show you all these components. Okay, I'll show you all of them. We will engage ourselves in all this activity. We will learn the labeling of a resistor. Okay, we will learn all these things physically. Okay, so don't worry, just go and read. We have schematic diagrams and symbols. So when you see this symbol, they are all capacitors. Okay, this is a symbol for capacitor, but this is a non-polarized capacitor or a fixed capacitor. Non-polarized capacitor. Okay, this is a capacitor with polarity, which has negative and positive. Normally, non-polarized capacitor, they are usually the ceramic or the mica-based capacitors. Then the electrolytic capacitors are the polarized capacitors. These are spring pots or variable capacitors. Okay, variable capacitors. The arrow shows that it is variable. That means you can change its capacitance by tuning. These are coils. Okay, these are coils or inductors. All right. These are transformers. Look at the symbol. That's a transformer. So these are the process of using a transformer to generate, to transfer energy. Now the primary winding, then the secondary winding, without contact or without contact, it is transferring power. So this is a crystal oscillator. When you see this symbol, it's a crystal oscillator. One day I'll show you some. So we put on this on a breadboard to create a circuit, electronic circuit to function. All right, so this is a memristor. Okay, these elements change its resistance according to the value of the voltage directed to it. You see that? It is a new technology that may change the electronics industry considerably in the future, except that this element is not used in the known devices we have so far. So this is it. It is there. I have this chip. Okay, I have this chip in my office. I'll show you when you come. So we have switches, so many types of them. Okay. Then we have the relay, almighty relay. This is a device that will use DC to control AC. Okay. One of the very old devices. This is a mechanical relay. Then we have the speakers. We have the motors, different types of motors, and motor control, motor parts and components, different types of motors. Then we come to rectification. So I'll start the work itself from here. Now you start this. I cannot take this right now. We have to wait and take it at the right time. Okay. When are we supposed to end the class? When are we supposed to end the class, please?
Yes, sir, we are supposed to end 3:45.
Ah, who is speaking? Engineer Philip.
Yeah.
So far, you're the only one speaking. Oh. Roll call. Please turn on your cameras. Let me see all of you. Then I'll mark you.
Please, we beg you.
we,
Some
we
of
are
us not here.
the background, the background.
We beg, we beg, we
Okay,
beg.
okay. Okay, it's well understood.
Turn it.
We beg.
Hey,
Misuse.
why are you begging? Where are you?
Go back.
Hey, you're going back.
Some people are going back.
Ladies,
Go back.
Hey,
ladies supposed to be in kitchen, so you can be on kitchen side this afternoon, then you take that picture.
Master, are you there? Are you there? Anyway, so we will continue, God willing, but we have to still get opportunity to have another class. Okay.
Okay, sir.
We will end it here. But please, my assignment. How do I get it?
So where should we submit it?
You can send me via mail.
Please,
So then you have to give us the mail.
the mail when you say it doesn't go.
Is it?
So you have to give us the mail.
Don't worry, okay, don't worry. Keep it, okay?
So please come in.
I say keep it, okay?
So that when we meet face to face.
Yes, when we meet, then I'll take it. Okay.
Okay, sir.
But what I want you to do for me, seriously, I want you to go back and read the materials.
Okay.
Okay, I was told that you don't have the materials. I'll send it to you right away.
So
Okay.
we have.
Yeah, then why is your class rep saying you don't have? Or is it? Oh, sorry, maybe it's not the auto that it doesn't have. It's a different class. Okay. So let's meet again. We'll find an ample time to have an online meeting. Okay.
Okay, sir. We will
Okay,
arrange
sir.
it.
Okay, sir.
Thank you very much. Thank you for coming.
Okay, sir. Thank you.
Have a nice day.
You too.
You too, sir.
YouTube. We say YouTube over here.
Hmm? Philip, please, are we using the same platform or we have to join a different platform for
I'm
the
going
break?
to join. Once it's French, you are going to join.
Yeah, we are
Please,
going to join.
please,
You don't
I
know
said,
French.
please go and check your WhatsApp. Please kindly go and check.